Welcome back. This is the last part of the series. How do we make conclusions based on what we have found? So remember, we ended with finding the p-value. We got some number. Great. What do we do with it? That's going to be the focus of this last section. But before that, let me give you a quick analogy here. If you are on trial by jury in America, there are two rulings that can be given about your case. You can be found guilty or not guilty. The jurors aren't actually charged with deciding whether or not you are innocent. At no point do they have to prove you're innocent. In fact, they're supposed to assume that you are innocent and prove only that you are guilty. And hopefully this will give you a bit of an idea about the phrase reject or fail to reject, guilty or not guilty. That is what's going to happen in this series when it comes to hypothesis testing. In hypothesis testing, just like in the trial by jury, there are two outcomes. You either reject your null hypothesis or you fail to reject. It's either guilty or not guilty. You either reject it because it's wrong or you fail to reject it because you don't have enough evidence to do so. So just like in a trial by jury, you assume the null hypothesis is true and try to see if there is enough evidence to prove that it's not true. So if you've got enough evidence to prove it's not true, then you reject your null hypothesis. You say, well, whatever I thought was true, clearly it's not. But if that doesn't happen, if you don't get enough evidence, you just say not guilty. You fail to do anything. In the same way that someone who is not guilty is not necessarily innocent, so too is it that when you fail to reject a null hypothesis doesn't mean it's actually true. Right? We're not assuming the claim to be true. We're just assuming the null hypothesis is true and seeing if that's wrong. So I think that's what I just said. Yeah. Okay. So here's how it's going to go, start to finish. This is everything we've done this whole video series, from video A to video whatever letter this is. We got a test that we're going to want to make. We can make some hypothesis based on some claim. We make the null hypothesis, which is our focal point. It's also our working assumption. We assume the null hypothesis should be true. We make our alternate hypothesis, which differs from our null. We decide on our significance level. 0.05, you got nothing better to do. We get some sample data, whatever it is. And then we find the p-value, either using test statistics and table lookups or using technology. Either way, you get some p-value or critical area or whatever. And in either event, you get some p-value. Here's what happens now. The higher your significance level, the harder it becomes to reject the null hypothesis. And that's because samples are random, right? If you set the significance level to like 0 perfectly, then you can never ever reject because you've just made it impossible to do so. Let me give you, again, let's return to our trial by jury example here. Let's suppose the person is truly guilty, that they did it. They deserve to be punished by whatever rule. Well, let's say that our significance level is either too high or it's too low. You can never have a perfect significance level. That never happens. But let's say we have a burden of proof that was too generous, too lax. For instance, alpha 0.5, we allow 50% to go through. Then we run the risk of having a guilty person not be punished. On the other hand, if it's too strict, well, that's okay, right? The person's guilty. We found that they're guilty. Yeah, okay. Conversely, if your burden of proof is too generous or too lax, well, if they are innocent, that's not a problem. On the other hand, they might be wrongfully punished if it's too strict. The same will happen for our findings with alpha in general statistics. More to come in the next video.